Hey everybody. I'm going to spend some time right now going through the worksheet that we did on Tuesday. So it's going to be the ion formation practice. I know we only really got to talk about cations together, and then I had you just watch the video for anions. So I'll talk about those a little bit as we kind of go through these formations and check the work that you've done. Hopefully, as I go through this, I'll answer a lot of the questions that I've been getting via email. If these don't answer your questions, definitely send me emails and we can touch base at that point, okay? So looking at the very first one, our chlorine ion. There are a couple different ways that you can do this for your valence electrons. Remember that I did show you a cheat, which I have just here to look at really quick, but you would need your periodic table. That for valence electrons, you can actually look at the number at the top here, and that corresponds with how many valence electrons there are in that column. So for the very first one, you're looking at chlorine, which is going to be down here, which means that you would have 7 valence electrons there, okay? So that's the very first thing that we can look at. The other way that you can do this is if you were to draw your Bohr model. Chlorine has 17 regular electrons. So if we start with our chlorine in the center, we draw the Bohr model. So we have the first 2 here. The next circle is going to have your 8. And that last circle is going to have that remaining 7. So again, looking at the valence electrons, which is this outermost shell, you will have 7. So valence electrons, 7 valence electrons. Okay. So will it gain or lose electrons? Think about it this way. Is it going to be easier for it to gain that one empty electron space that it has open, or lose all 7 that it has on that shell? So obviously just gaining 1 is going to go a lot easier. So for this, it will gain 1 electron to get to that full shell. Okay. So looking back at our notes, is it a cation or an anion? Remember, cations are going to give away electrons. As they give them away, it gives them a positive charge. Anions are going to gain electrons. As they gain electrons, it gives them a negative charge. So this one, because it's going to be gaining that electron, it will be an anion. The ion charge, because we're only going to be adding in this 1 electron here, it will be a -1. So then coming back up to the top then, the chlorine ion would be Cl-. And then the electron configuration for the ion. So we're going to be looking for the ion, not the regular chlorine, but instead the new stable one. So here we're going to be adding in that extra 1 that extra 1 electron for chlorine. So we're now going to have the 2 plus 8 is 10 plus 8 is 18. So the electron configuration is going to be all 18 electrons. If you have your periodic table with you, it would be 1s2, that's going to take care of the hydrogen and helium. 2s2, that's going to take care of lithium and beryllium. 2p6, which will take care of boron through neon. 3s2, which takes care of sodium and magnesium. And then 3p6, which will take care of aluminum all the way through argon. Again, it usually is 3p5 for regular chlorine. We stop at 5, but because we have this 1 extra electron here, you add in that extra electron here as well to give you that 6. Okay. looking at our sulfur. So sulfur is going to be pretty similar to chlorine. It has 16 electrons regularly. It is in the 16th column. It's in your oxygen family. So in the 16th column, 16th, drop that ones unit, it has 6 valence electrons, but just in case you need to see it, we have 1, 2, 3, 4, 5, 6, 7, 8. So there's 10. Alright, so this one is going to have 16 electrons total. This outer shell here for your valence electrons right now has 6 electrons in it. Again, full shells like to have 8, so it is going to be easier for it to gain 2 electrons than it is going to be to get rid of those 6. So how many valence electrons do we have? We have 6 valence electrons. Will it gain or lose electrons? We are going to gain 2 electrons. Is it a cation or anion? Remember, cations like to give away electrons to become positive. Anions like to gain electrons and become negative. So this one again would be an anion because it is gaining those electrons. What is the ion charge? We're going to be gaining 2 new electrons. So again, how we're getting that charge, sulfur in the nucleus usually has 16 protons. If we are gaining 2 more electrons here and here, we are going to be ending up with 18 electrons. We've talked about how protons are positively charged, while electrons are negatively charged. So when you figure this out mathematically, you're going to have 16 positives and 18 negatives, which gives you that -2. So this is where this negative charge is coming from, -2. Again, and it's also because these 2 electrons are being added in. From there, you can figure out your sulfur ion. So from here, sulfur is S, and it would be a -2. And then what is the ionic electron configuration? So again, this isn't going to be the configuration for sulfur, but instead that sulfur ion. So we're adding in these 2 electrons here to that overall configuration. So starts the same way as our chlorine that we just did above. 1s2 is going to take care of our hydrogen and helium. 2s2 takes care of lithium and beryllium. 2p6 goes all the way across from boron through neon. 3s2 takes care of sodium and magnesium. And then usually we end at 3p, 3p4 to get to sulfur, but because we're adding in these 2 electrons here, we're going to be going up to 6 again. So 4 plus those 2 equals 6. So 3p6. All right. Arsenic. Arsenic is going to be a little bit of a bigger one. So this has 33 electrons to it. I would recommend just using your periodic table so you don't have to draw this one. So arsenic is here. If you look at your column, it's in column 15, so there are 5 valence electrons. So 5 valence electrons. Again, if you need to draw that Bohr model, feel free. Will it gain or lose electrons? So again, in that outermost shell, so here's your outermost shell, you have 5 valence electrons. 3, 4, 5. It wants to have 8. It's going to be easiest for it to just gain 3. So it is going to gain 3 electrons. Again, anions like to gain electrons and become negative. So here this is an anion. The charge, because we would be adding in basically 1, 2, 3 to make it to that 8, it would be a -3 charge. Again, this is because arsenic is going to have 33 protons, which are positive. We originally had 33 electrons, but we're adding in 3 more, so it's going to be 36 electrons. So that gives us a -3. And then that ionic electron configuration, remember we're adding in these 3 new electrons here. So it's going to be larger than what our normal configuration would be for just arsenic. This is now going to be the ion for it. So as we go across, we're going to go ahead and use the noble gas notation. We're going to start with argon. Sorry. So we're starting with 18 on the periodic table, argon. We are then going to 4s2, which is going to take care of potassium and calcium. Got to go into that 3d10 to get all the way across those transition metals. And then we're going to go back up to the 4p. And then again, because you're adding in those 3, originally it would be 4p3. But because we're adding in 3 more electrons, it's going to be 4p6. Okay. Aluminum. This one's a little bit shorter. It's 13 electrons to it. So in our very center, you have your 2. You have 8. And then you have your 3 to get your 13. So valence electrons, again, it's that outermost shell there. So we have 3 valence electrons. It is going to be easier for it to lose those 3 valence electrons. So basically, this guy here, let's try that again. This guy, and this guy are all going to be leaving, bringing it down a shell level. Okay. So this is going to be lose electrons. Because it's losing electrons and becoming positive, it is a cation. Remember, cats have paws, making them positive. How that happens, again, you have 13 of our protons. Since we are losing these 3 electrons here, we actually only have 10 electrons left. So plus 13 minus 10 is going to give you a plus 3. So our charge would be a positive 3, which here then we can write our ion as that. And then our configuration from there, I'm going to again start with neon just for the shorthand method. Neon is number 10. It's then going to be 3s2. And then that's where we end it. I lied. I was doing the regular one. So sorry. Okay, so we're losing these 3 electrons. So we're going to do 1s2 that takes care of your hydrogen and helium. 2s2 takes care of your lithium beryllium. 2p6 takes care of boron all the way to neon. Then normally you would add in your 3s2 for sodium magnesium and then your 3p1 to get to aluminum. But because you're losing those 3 electrons, you're going to be stopping on that second energy level, which again here you can see with your Bohr model that you have 1, 2 energy levels. So you would stop at your 2p6. All right. Calcium ion. How many valence electrons are there for calcium? I'm going to, again, have you guys use your periodic table. Calcium is here. It's in column 2, so there's 2 valence electrons. It's going to be easiest for it to lose those electrons because it's losing them and becoming positively charged. It is a cation. All right, so if you think about it, calcium usually has 20 protons. We are losing 2 electrons, so that means we now only have 18 electrons. So it's going to have a positive 2 charge. So we can write that as Ca plus 2. All right, so again, we're losing those electrons. So when we write this, I'm going to start it at neon just to make it go a little bit quicker. So we're starting at neon, which is number 10. We're then going to go to 3s2 to cover your sodium magnesium, 3p6 to cover your aluminum through argon. And that's actually where you end, because you will not need to add in your 4s2 to get to calcium because you are losing those 2 electrons. So here's where you would stop. Lithium. This one's a little bit shorter. We can draw this one. So lithium, we have 2 here, 1 here. It has a total of 3 electrons in lithium. So it has only 1 valence electron. It's going to want to lose that 1. It is going to be a cation because it's losing that electron to become positive. The charge, so again, if you're losing this electron over here, it has 3 protons usually. You're losing the 1 electron, which means we actually have 2 electrons there. So when you add that together, you are going to have a positive 1 charge to it. So positive 1, the lithium, when you write that, would look like that. And then again, you're losing that electron, so lithium's actually really easy to write because it would just be 1s2 as its ion. Right, iodine. Iodine is going to have 7 valence electrons. I would just use the cheat sheet on the table to figure that part out. Again, if you wanted to draw it, you can, but there's 53 electrons in iodine. Because it has 7 valence electrons and it wants to get to 8, it's going to gain electron. Oh, 1 electron, sorry. Because it's gaining 1 electron and becoming negative, it is an anion. Since it's gaining 1 electron, it is going to be a negative charge. Again, how that you would figure that out is usually 53 protons, which are positively charged. You're adding in 1 electron, so you would have 54 electrons, which are negatively charged. When you add those together, you get a negative 1. You can then write that, so iodine, negative 1. And then you can write the ionic electron configuration. I would again use the shorthand, so start with krypton. From there, you would be at 5s2, 4d10, and then 5p6 to get all the way across to that full outermost shell. All right, potassium ion. Potassium has 19 electrons in it, 19 protons in it. Valence electrons, it only has 1. It is in that very first column, so that's how it's the quickest way to find that. Again, first column has 1, all of them do. Will it gain or lose electrons? So it is going to want to lose that electron. Because it's losing 1 electron, it's going to end up being positive, so it is a cation. The charge, so again, if it's losing an electron, we're going to be at 18 electrons, which means we're at a +1. Sorry, my plus sign didn't turn out there. And then the electron configuration. So again, since we are taking that one electron away, you're going to actually end up with the same electron configuration as argon, which is 18 on the table. So if you want to do shorthand, you can start at neon. And then 3s2 is going to be your sodium magnesium. And then 3p6 takes you to where you need to be. All right, oxygen has 8 protons to it. If you again look at the column it's in column 16, so it is going to have 6 valence electrons. 6 valence electrons is super close to 8, so it is going to want to just gain 2 electrons to get to that full 8. Since it's gaining, it's going to be negative, so it'll be an anion. So if we're gaining 2 electrons, that means we're going to have a total of 10 electrons. So it would be a -2 charge. So oxygen, -2. And then the configuration for this one, we would have 1s2. That takes care of hydrogen and helium. 2s2 takes care of lithium and beryllium. Normally it would be 2p and then we would just go to 4, but we're adding in these 2 extra electrons here, so it would be 2p6. And then the very last one, valence electrons for barium. Barium has 56 protons and electrons. It is in column 2, so it is going to have 2 valence electrons. Because there's only 2, it wants to lose 2 electrons to become stable. If it's losing 2 electrons, that means we're going to be having 54 electrons there. Again, if you do the math here, then you'll find that it will end up being positive. So positive, it is losing those electrons, so it is a cation. The ion charge is that +2. So we know barium Ba +2. And then that ionic electron configuration. So we can start at krypton. Krypton is 36 on the table. So then we would be at 5s2, which takes care of rubidium and strontium. We then jump down to the 4d10 to get across all the transition metals there. Back up to the 5p6 to get to where you need to be for xenon. And that would be it. Alright, so that goes over all the answers for the worksheet that we did the other day. You can always back up the video to check any of them that I may have gone too quick on. This I have just for us to kind of reference back to as we look at some of the stuff here. So basically what we are looking at now is we have our ions, we created our ion formation, but how do we still get to those compounds? Right now we just have basically elements that have positive and negative charges. So what's next? So we're going to look at a couple examples. So first we're going to look at sodium. Sodium is 11 protons. On the periodic table, so it's in that first column, so it has 1 valence electron. Because there's only 1, it's going to want to lose 1 electron. This makes it a cation. And then the charge is going to be a +1. Again, it's losing 1 electron, right? So it'll only have 10 there then. So 11 minus 10 gives you +1. All right, so we have sodium, that's sulfur, sodium +1. All All right, on the flip side of this, we're going to look at fluorine now. It has 9 protons. It is in column 17, so it has 7 valence electrons. Because it's so darn close to being 8 valence electrons are being stable, it's going to just want to gain 1 electron. This makes it an anion because it would end up being negative. So again, how we would get that is it usually has 9, it wants to gain 1. So it'll now have 10 electrons. Plus 9 minus 10 gives you negative 1. So the charge is negative 1. So looking at these two in comparison, we have up here sodium, which is a cation, fluorine, which is an anion. In order for us to create compounds that are ionic, you need to have one of each. So that's the very first step. You always want to make sure that there is one cation, one anion. The reason for this is because you have these charges, right? Positives and negatives are going to attract to each other, just like when you think of magnets, the south pole end and the north pole end are what attract to each other. The opposites attract. So here you want your positive and your negative to attract to one another to create that chemical bond. So you always have one cation and one anion. From there, you want to make sure your charges match. So here we have sodium, which was a +1, and you have fluorine, which is a -1. +1 minus 1 is going to equal 0, which means it is a neutral compound. It means it's going to be happy. That's exactly where it wants to be again. So here, each of these atoms can now be completely stable with their outermost shells being where they want to be, and they're still going to be able to be neutral because they're going to bond together. So how you would write this then is just going to be NaF. Now, I did mention in the video when you name this, the first part, so your sodium here would stay the same. Your fluorine, whenever you are turning it into an anion, the endings usually end in "ide" then. So this would be technically sodium fluoride. Okay. So it's literally that easy. We're going to go through a couple of these just to kind of get some practice in. And then there's going to be problems at the end here that you'll be able to do in a, like on a separate sheet of paper and then throw into a Google Doc for me. Okay, so look at magnesium. Magnesium has 12 protons. It's in that second column, so it is going to be 2 valence electrons. Because it is only 2, it's going to want to lose them. Because it's losing them and becoming positive, it would be a cation. So if we're losing 2, that means we're going to end up with 10, which means it's a +2 charge. So here magnesium, +2. Oxygen, on the other hand, we have 8 protons. It is in column 16, so there are 6 valence electrons. Because there are 6, it is going to want to gain 2. It's going to be the easiest thing for it to do. So if it's gaining 2 electrons, we're now up to 10, which means it's going to have a -2 charge. And again, because it's negative, it's an anion. All right, so again, this is a nice, easy one. We basically have the +2, -2, one's a cation, one's an anion. So everything's lining up pretty perfect. So if we have the Mg +2 plus O -2, you're going to end up which is MgO. And this is because +2 plus your -2 is going to be 0. So again, it is a neutral compound. That's exactly where it wants to be. So let's kind of flip this around now and make it a little bit harder. Sodium and oxygen. Well, I guess I should mention, so up here, when we looked at magnesium and oxygen, this would now be magnesium oxide. So again, the ending of your anion changes. So magnesium oxide. All right. So let's look at sodium again. We already figured it out. It was a Na+1. And oxygen, which was O-2. So if you actually look at these, you have a +1 -2, which still equals -1. So it's not neutral. It's not where you want it to be right now. So this is where, when we were doing counting atoms and we were starting to work with subscripts, that's where this is going to come back into play again. So to make these two neutral, you're going to want to increase your cation to match your anion. So if I were to have 2 of these sodiums, I would then have 2 times my 1. So that would be a +2 -2 equals 0. So that's how it would be neutral then. So how you would end up writing this would be Na2O. So again, here, this 2 is signifying that we have 2 of our NAs, which are both positive 1s. So that's a +1, +1 for each one of those. And here is our -2 for oxygen. So when you add that together, +1 + 1 is +2. -2 gives you that 0. And that gives you exactly what you need. Oops, except I erased my oxygen. And that gives you exactly what you need to make it a stable compound. Okay. So the practice problems, I'm going to kind of scroll through. It's going to be doing the exact same thing that I just did above. I want you guys to work these out on a separate piece of paper or just in your notebook. And then you are able to go to Google Classroom. I have a Google form that you can go in and throw just the compound part down here into that section. So the first one, you're going to look at potassium. Again, look at the valence electrons. Will it gain or lose? Cation or anion? And what's the charge? You're going to then look at chlorine. And then you're going to make that ionic compound. So if you need to, pause this so you can work these out. Number 2, calcium and sulfur. Again, you're going to make that ionic compound. Number 3, lithium and iodine. Make that ionic compound. Number 4, sodium and oxygen. Make that ionic compound. And the last one, number 5, calcium and chloride. Make that ionic compound. All right, and we will touch base with all of this tomorrow before we do our practice problems that kind of go into this a little bit more. So just make sure you get this turned in on Classroom. If you have any questions, let me know. Hope you guys are all doing well.